Here is the question. It says, test the series for convergence or divergence. First, when we look at the series, observe that the signs are alternating, right? So this is an example of an alternating series. So maybe we can use the alternating series test. Let's see how we can write the series in more compact form first. So what is the term? The first term is 1 by natural log of 3. The second term is negative. So the first term is positive and the second term is negative. So the negative signs are coming from negative 1 power n minus 1. Okay. And the content of the term is 1 by natural log of something. What is that something? You guys notice when it is n is 1, this is 1 plus 2, 3. When n is 2, log of n plus 2. So I'm guessing this is the term, right? So my alternating series can be written as this form, where Bn is equal to, what is Bn? Bn is the positive part of the term. So that is 1 by natural log of n plus 2. To check AST, I need to check two conditions. Part 1, that limit n approaches to infinity of Bn is equal to 0. And the second condition is that Bn is decreasing. That means that Bn plus 1 should be smaller than Bn. Okay. That is smaller than or equal to. That's what we need to prove. Okay. So let's try checking the first condition. First condition, limit n approaches to infinity of this. We know as n approaches to infinity, log of infinity approaches to infinity. So the denominator is approaching to infinity. If 1 by infinity, that is going to whole approach to 0. So that is clearly, easily checked, right? What about part 2? We need to prove that this is decreasing series. We know that n plus 2 is more than n, right? The next term. So let's do the next term. So we want to prove that Bn plus 1 is less than Bn. What is Bn plus 1? 1 by natural log of n plus 3. What is Bn? 1 by natural log of n plus 2. Now, I have to prove that Bn plus is less than Bn. That is my question. Okay. How do we prove that? We know that n plus 3 is more than n plus 2. Everybody knows that. If I take log both sides, it is still more than log of n plus 2. Why? Because log is increasing function. Okay. Now, if you have an inequality and if you reciprocate it, so 1 by log of n plus 3 and the other side also 1 by log of n plus 2, that has to be less than. So whenever we have an inequality, if you reciprocate it, it flips. What is this? This is Bn plus 1 less than Bn. That proves that Bn is decreasing series, right? So because we proved both the conditions of AST, we can say the given series converges using alternating series test, AST. Here we have another example. And if you guys notice, this is also an alternating series. This part tells me that this is an alternating series. So I can try to use AST's conditions here. Okay. So let's try the first condition. First of all, the positive component of your series is your Bn. 3n minus 1 divided by 2n plus 1. Okay. So we need to first check if limit n approaches to infinity of 3n minus 1 by 2n plus 1. We need to prove that this limit is equal to 0. Let's find this limit. How do you find this limit? you check the limit is to infinity. So you check the highest power of n in the denominator is what? 1. So you divide everywhere by n. So 3n minus 1 divided by 2n plus 1. I'm going to divide all the terms by n to find this limit. That's going to look like 3 minus 1 by n divided by 2 plus 1 by n. We know that 1 by n is going to approach to 0, and this 1 by n is going to also approach to 0. So this limit is basically 3 by 2. Is 3 by 2 equal to 0? No, this is not. So our first condition of AST is not applicable, is not satisfied. So AST is not applicable in this, okay? That is your first takeout. AST is not applicable, even though this is an alternating series, because the first condition is not satisfied. So AST is not applicable. But you know what? If you notice, what is the whole term? The whole term is negative 1 power n times 3n minus 1 by 2n plus 1. If I have to take the limit of that, that is also not gonna be equal to 0 for sure, because the positive part of this is approaching to 3 by 2. When I'm adding negative 1 power n multiplied with this, it's going to just oscillate between negative 3 by 2 to 3 by 2, right? It's never going to approach to 0. So this says that limit n approaches to infinity of an, the whole term, is not equal to 0. So here we can use divergence test. Divergence test says what? If limit n approaches to infinity of an is not equal to 0, then the actual series diverges. So what can we claim? That the given series, this one here, this series here, n approaches to 1 to infinity, negative 1 n minus 1 times 3n minus 1 by 2n plus 1, diverges using divergence test. So AST did not apply here, but AST did give us a clue that if just the positive part of the series is not converging to 0, then the actual whole sequence part term will also not approach to 0. If that is not approaching to 0, then divergence test can be applicable to tell that the series is divergent.